Thanks everyone for coming. I guess I'll go ahead and get started. It's already about 11:30. I either have the least or the softest end time or the hardest end time since lunch is just after me. So we'll kind of see what I'm, getting feedback as we get closer to end time, if it's hard or soft, if people really want to get to lunch. So my name is Billy Korando, developer advocate with Oracle. Maybe you've heard of us. And you can also find me on Twitter at Billy Korando, where I spend 2 months of my time. And this is going to be to Java 20 and beyond, but really I kind of actually want to make it to Java 21 and beyond because it's just going to be a little bit more interesting because there's a lot of cool features coming to 21, and I imagine many developers here are going to end up using Java 21 at one point or another. Actually, a really important thing going to be, I've given this presentation before, but I've updated a bit, and I've noticed it's starting to get a bit full. And I want to kind of see, so if we could get like a show of hands, like everyone who's at least on JDK 8 or above, like hold your hand up. Okay, 11 or above. Is anyone on 17? Okay, good amount gone down. And then is anyone looking to get to 17 or above or 20 or above here pretty soon, like in the next year or so? Good amount? Okay, all right. So yeah, I think I might start focusing more, getting into 17 and beyond. But yeah, there's a lot to cover, and let's just go ahead and get started. But important information, please feel free to ask questions at any point. Continually just scan the audience, just raise your hand, and we can, make sure everyone's getting the information they need, because I'm here to let you know about what's kind of going on. And like I said, that's going to be primarily focusing from Java 11 to now Java 21. So my point is to help inform you about all of that. And you can get a link to this presentation at this link here. So, any information you may have missed, you can just go to check it out there, and also make sure to get this updated here after this presentation's over on my GitHub. And if you leave with an intense desire to know more, we have a lot of great resources. We have our site, dev.java, which covers a bunch of different things about Java, including also community aspects like how to join a jug or the various jugs around the world, and also how to find conferences like the great Devnexus conference. We also have Inside Java, our YouTube channel, and then on our YouTube channel we have a bunch of different great shows and podcasts as well. That said, our agenda, we're going to first look at some of the new language features, then we're going to get to some API updates, new runtime features, deprecations, removals, and then eventually we're going to be kind of looking a bit into the future of Java as well. So let's get into the new language features, because I figured that is mostly what maybe initially sometimes Java developers think is when changing between the new upgrading versions. So text blocks, these were added in Java 15, and their JEP is 378. If you're not familiar, JEP stands for JDK Enhancement Proposal. So whenever there's a somewhat substantial change being made to the JDK, it goes to the JEP process just to make sure that we're properly reviewing it, getting an opportunity for feedback, and also with like language features, usually that's going to go through at least 2 rounds of preview as well to get some feedback on those features as well. But if you go to here, openjdk.org JEPs, openjdk.org JEPs, you can see the full list of all the JEPs that are now actually been accepted, including also in the future some like draft JEPs as well. But yeah, you can go here, and you can read all about the history and from background information on a JEP. It is a really great resource on understanding some of these features in more depth than I can really get into in this presentation. The text blocks, they are adding 2-dimensional strings to Java. So of course we're all familiar with a 1-dimensional string, and here I have a simple JSON message. But quickly, because of like all the formatting we need to do and having to break up the string, it becomes very confusing and distracting to look at. And while it's simple enough and we're probably familiar enough with it, we know what's going on, it can also become very easy to introduce a bug, maybe forget to add a colon somewhere or a comma somewhere, or you leave it out. If you get to add a colon and leave it out, it would be very easy to miss that in all this mess. So text blocks are added. They're denoted by 3 quotes, then a carriage return, and then here also like a lot of formatting is relaxed, so you no longer need to escape a double quote or anything like that. So it just makes it much cleaner, and really just makes this string, what you see is what you get. So all this formatting here, this indentation is also preserved. And the one big thing also was based upon really where this triple quote is, or is all the white space to the left of it will then be ignored. Really, probably just as a good general rule, keep the triple quotes to the wherever you want that white space to be ignored to. Then you want to kind of get into some of the potential weirdness about what white space is removed or isn't. But fundamentally, text blocks are just normal strings. So if you want to format a text block string, like I have in this case, if I want to replace values from it, I can still just do that just like I could any other string because, well, that's what they are. Now, maybe you have like a whole lot of text that you want to put into a text block, but you still want it to be printed out on a single line. Then on as the very last character of a line, you put a backslash, then it will ignore that carriage return, and then it'll, print it out. I guess having this example, and it'll be just like a single line of text because I have the backslash on each of the last of the lines. And because also I put the triple quotes here at the end, there's not going to be an additional carriage return after the period here. Just make sure if you're ever doing this that this definitely is the backslash is the last character, that there isn't any white space after that or any like spaces, because then that will be interpreted as the last character on that line. So, that could lead to some potential weirdness. But for more information on it, one of our developers, Stuart Marks, he put together a programmer's guide to text blocks, which again gets into more of the depth on some of those rules around how text blocks work. So would definitely recommend checking that out. So pattern matching pattern matching is going to become a much bigger story within Java. I'm actually kind of glad that when I first started giving this presentation, this is about all I could really talk about with pattern matching, but now we'll see here in a few minutes also how this story is expanding quite rapidly, and it's going to really kind of simplify a lot of the work when it comes to working in Java, when it comes to working with data. So pattern matching for instance of, we've all probably written instance of a couple of times here. It's not super common, which is part of the reason why we kind of started with we started the pattern matching story with instance of, just because it's relatively lower stakes. But here we see the example of, we have some sort of object. We don't know quite what type it is. And so it could be any of these different number types. And it's like, okay, we'll test to see if it's an integer. If it is an integer, okay, we'll set the variable for it. But then we again need to recast it to say it's an integer, even though we know for sure it is. So it's just messy. And it, could also potentially become a little bit error prone, as we can maybe kind of see here. If you have a bunch of if-else's going on, there's some opportunity to introduce some errors there as you're refactoring it or adding to it. So now, pattern matching for instance of, so what we have here is the test, just like we did before, where it's like, okay, is this object an instance of this type? And if it is, then it will set it to this pattern variable that will then be in scope for wherever the compiler definitely knows this to be true, or wherever it definitely knows it's set. 99% of the time that this means it's going to be in scope for the following if block. But also of course it's still obviously in scope if we do an and to do some sort of additional test on it. It will be in scope for it as well. But what's also nice is you can notice here that I am using I in all of these different if statements. And that's because they're actually all separate variables as far as the compiler is concerned, because again, this I would only ever be in scope for here if it's ever set. So they can also allow, you don't have to come up with arbitrarily different variable names in a case like this where you maybe have, you're setting it to the same kind of type or a similar type where, in this case, I or X or T or whatever it might make sense would make the most sensible variable. You're not going to have to kind of arbitrarily come up with different variable labels within a if-else, or maybe we'll see a little bit later for a switch as well. But to kind of drive a point home about what the scoping is around these. So here, I is in scope, and it's in scope for this if block, but then once we leave it, it's out of scope. Here, if I was just to have a test statement, and I have this now I'm a string, it would be in scope in here in the parentheses, but it would be out of scope once I leave it. And then if I was to do testing to see if something's a string, If it was to do it then as an R, that would be out of scope because the only way we could get to this R if the instance of was false. And not that you should ever do any of this, but if I was to put a not in front of this, then it would be in scope in the else part of the statement. Or if it was like if I put like a not and then an exception, then it would be in scope outside of that if block, because obviously the only way I could get to this if this was false. Don't do any of this stuff because it would be very confusing, but it's just to kind of really show that it's not like some sort of hard coding of this flow scope variable or the pattern variable being in scope following the if block, but it's actually because of the logic of wherever that's definitely set by the compiler. Sealed classes, this is also something that's finally much more interesting to talk about for reasons we'll see here in a couple of minutes. But sealed classes, at least already, if you're just now on Java 17 or about to get to Java 17, are still useful. So every place I used to work at before I became a developer advocate, we all have like certain kind of key concepts that you have. Like in this case, I have like user, could be customer, transaction type. You kind of know what I'm talking about, where there's going to be like a limited set of them, but you can't really necessarily define that set. Here, like a lot of places you can say like, okay, we have user, and there really is only 3 user types we're maybe ever going to work with. And before there's no real way to show that, you would just say like, you would just explain it to each other, but like, oh, okay, yeah, there's only 3 types of user, I guess, a customer and admin. But now with sealed classes, we can actually define, a class can actually define who can extend off of it. And so here it's like, yeah, guest, no one extends off a guest, so it's final. Customer, could be many types of customers, so we're going to allow that to kind of grow organically as new customer types are needed. And admin, there could be only ever 2 types of admin, a super admin and a normal admin, which itself can also kind of expand organically. And so what that actually looks like in code then is the new keyword sealed was added. And here, then there's an optional keyword permits, where it said, okay, class or the class user is permitting admin, customer, and guest to extend off of it. And these are only 3 classes that can extend directly off of user. Then, as a result, these 3 classes would then either need to define themselves as non-sealed, which basically means it is now a normal class and anything can extend off a customer in this case. Final, of course, we're all familiar with that, or sealed itself. Now, as I mentioned, permits is optional, it's not required. So if you're going to define or reference subclasses that are outside the source file in which you're defining a sealed hierarchy, then you would use the permits clause. If you define other classes in the same class as a sealed class, then these are the only classes that extend off of it. So it's mutually exclusive. You can't do permits and then also define other classes in the same class file. And it could be either inner classes, like in this example, or it can also be classes at the same level within that source file. So it doesn't have to be inner classes like I showed in this example. So Switch saw several updates back in Java 14, and then also a few more updates a little bit later, which I'll get to. But yeah. Again, we're all familiar with the old colon syntax, and it's very noisy. Even in this, simple example of 7 cases that are just using one statement, I had to scroll on the screen to do that. But beyond just being verbose, which is annoying, there's also opportunities for introducing errors. You're working on it, you're refactoring it, you're adding a new case, and maybe you accidentally, leave a break statement out, and then now all of a sudden you're going to have some sort of bug if you don't have like a test that's covering this that you get before you deploy to production. And now whenever it hits on Friday, then it also then falls through to the following case that also then performs that behavior. So now there is the new arrow syntax. So just to be clear, of course, colon syntax is still completely valid. You're not going to have to change all your switch cases. But now we added the new arrow syntax. And with the arrow syntax is only the code to the right of the case label will be executed when that case label is matched. And as we can see, it greatly simplifies it. So now you're not having so much of the distracting structure of that switch case. You can just more focus on the actual business logic. And then it's also less error prone because you're not having to add a break statement after each of these cases to say that you don't want to have the following case executed as well, so less error prone. So you get like multiple case labels, like 1, 2, 3, or something like that. Right. Yeah, you could do that. So then also, switches can also be written as an expression. Like in this case, where I am yielding a value out of this switch. When you write a switch as an expression, it has to be exhaustive, which, well, of course, we'll also see a little bit with pattern matching for switch, but most of the time that will mean you'll have to have a default case when you're writing it as a switch expression. But also, if you're using the arrow syntax, whether you're writing this expression or as a statement, if you do need to write out multiple statements or just some sort of more complex logic for that case, then you can just throw it into a code block and write out what you need. If it's an expression, then that case would need to end in either a yield or throw an exception here, like we saw in this example. But as and also, of course, you can write a switch expression using the colon syntax as well if for some reason you wanted to do that. But the last thing is, as I mentioned, most of the time when you're writing a switch expression, you'll need to write a default case, but you don't always need to write it like that. In this only example right now for JDK17 and before, if I was to write an enum and then I covered all the different cases of that enum in the switch, then I would not need to include a default statement because it is exhaustive. There's no other options available for what it could do. And again, the same thing can be done with the colon syntax as well. So the colon syntax isn't going away. We're just expanding what switch can do. Now we get to even more interesting here with pattern matching for switch, which should hopefully be added in Java 21. So right now the JEP for this is still in candidate status. It hasn't been officially targeted for Java 21, but it's very likely it will be. But yeah, the two big things is like if you're writing switch as a pattern state or using pattern matching for switch, then that switch must be exhaustive. Whether it's a statement or an expression, it will need to be exhaustive. And also switch can handle null as well, which can be really good if for some reason when going into that switch, you think null will be a somewhat common scenario. But simply put, here again, we have like a class and it's implementing, or it's an interface and several of them are being implemented. And here we can see, so if it matches on triangle, then we'll set it to T, and then in it, we can then do something with T. And then we also have a guard clause, which is defined with the keyword when, or the reserved word when, and we can do additional tests on it. So that way, instead of having to have like our case statement and then going into the case, maybe having an if, it's much clearer to say that only here, when it's a triangle, and then when it's a triangle that has an area greater than 100, is this case matched upon? Otherwise, it will then drop down to this case. And again, we can see here where I talked about with instance of, about how when the pattern variable is matched, it's only set for that variable wherever the compiler definitely knows it's true. We can see that same behavior here, where even though I'm using T for both of these case labels, the compiler sees this as two distinct variables because this T will never be in scope when this T is in scope because this can, because of the logic of the case. But again, because I'm using pattern matching here, even though I'm not writing, even though it's a statement and not an expression, it still has to be exhaustive. And as mentioned, you can also handle null as well. So it's adding a case label for null, and that way, if you don't just want to have an NPE to be thrown, you can actually handle that in some more graceful way. And where sealed hierarchies are now much more interesting is that the compiler can understand from that sealed hierarchy, like in this case, I don't need a null or I don't need a default case because the code knows that I am covering all the different subtypes of the shape interface or the shape sealed hierarchy because they are all covered in here. So you no longer need a default case. So that's also a really great way of also reducing potential bugs that, if you're building out a sealed hierarchy and then you add like a new type to that sealed hierarchy, you'll get a compiler error here because it's no longer exhaustive. So that's also a great way of how some of these things, it's not just necessarily like saving typing or anything, but it actually becomes safer because you'll actually start to get like compiler errors, and that way, that's going to really prevent you from getting to production when a change like that happens. Records were added in Java 16. Their JEP is 395. The first and most immediate way developers will see the benefit of records is in the great reduction in boilerplate code. So, here I just want to be able to define like a pretty simple class. But even a simple class, this takes dozens of lines to actually define between the constructor, the equals, the hash code, and all that. And of course, also if I was to add a new field or something to this, then I'll have to go make sure I update the equals and hash code as well. Now, that can easily just be replaced all in a single line. So all that dozens of lines of code before, covered in this single line with record. Now, of course, the point of records, why we did this, we didn't do it just to simply reduce boilerplate code. We didn't do it just because to replace, what is the name? Lambach. It wasn't done just to replace Lambach, but it actually has a theory behind it. The purpose of it is to be transparently modeling of data as data. So that way, in the definition of the record, you immediately know everything you need to know about this record, that it has 4 fields, the name of their field, or the components, and the name of the components. You can just look at that definition and really get a solid understanding of what that record is about. And that is because a superclass for a record is always going to be a record, so it can't be extended, can't be abstracted, and it's implicitly final. So again, you can just know there's not going to be some sort of additional fields or behavior being inherited from some sort of a superclass. All the fields of a record are final, but it's only shallowly immutable. So if one of these fields, like it was a list, depending upon the implementation of that list, you wouldn't be able to change the reference to it, but you could add or remove elements from that list, so you could potentially get some mutability there. So definitely when you're doing a record, perhaps in general anyways, but use an immutable list, so that way you're actually getting that real contract of like the record, once it's being set, it's not going to change. And also, make sure to follow good data hygiene practices of, returning a copy of a lot of these fields as well, if it is potentially a mutable object. But of course, as I said, accessors, hex, hash code, toString, equals are all automatically generated to you, but you can also override that implementation with your own. A good example is, like, let's say one of these fields was an array. When arrays, the default implementation of equals would do by reference, not by value, and that's probably not what you're going to want to do. You probably want to actually have them compare by value. So that's where it would be a case where you would override the default implementation of equals to have that array to check comparison by value, just to make sure that they're not two equivalent records. But yeah, here, example, overriding the default implementation of toString with my own, and then simply adding like an additional method, in this case toJSON, to automatically generate it to JSON. Also, so I mentioned that records, they can't have a super type, but they can implement an interface. And this is a really great way of, if you wanted to create sealed hierarchies with interfaces and records. We have an example, my example here with shape, and then each record, circle, rectangle, and all that is implementing shape. And then we can see from like the previous example of pattern matching for switch, how that pattern match or that switch can interpret saying like, okay, this sealed hierarchy, because I'm covering circle, rectangle, and triangle within it, I no longer need a default case because it's covering all the different permutations. I would definitely recommend reading the data-oriented programming in Java from Brian Getz, and it's really laying out both the records and then also a lot of the pattern matching and a lot of the features that are coming out of Project Amber, which is really a lot of these features I'm covering this language portion are all coming from. it kind of provides an overarching theory as to what we're kind of really going through with all these changes. It's not just like, oh, these all seem kind of cool and interesting, fun changes. There is like a larger idea on how we're trying to improve Java. And then finally, record patterns. And simply put, record patterns are a great way for deconstructing records. So simply put, here, using this instance of, I can then have my record of name easily take out the different fields or components from this record and then use it in the following if statement. And also records can be used with pattern matching for switch as well. So in the case label, I can match on name. Actually, I did this wrong. That shouldn't be the name here. It's just that part should be removed. But then reference the components within it as well, just to make it just that much cleaner and easier to use. All right, API updates. Sorry. Yeah. Uh-huh. Uh-huh. Yeah. Yeah, you would have to define your own method to do the clone and copy to do something like that. So yeah, I think that has been something that we've been kind of discussing at times on doing something like that. But withers, yeah, we've been kind of discussing withers to kind of do something like that to where you can update it more easily. But we just haven't, really settled on how we want to implement that yet. So hopefully here in a couple of releases, we'll actually have something like that to allow for that kind of behavior. Yep. So I don't know how many people were in here for the previous talk from Jose or a few, but so he covered, virtual threads is, I don't have enough time to go through it all, but virtual threads are lightweight threads. It's going to be the first finalized feature from Project Loom, which is the overarching thing of updating the underlying thread model. But lightweight thread model that can just greatly increase the writing maintainability and observability of it. So that way, if you want to have a really nice, massively concurrent application, instead of having to really depend upon features like reactive programming, which I personally can never get my head around, you can get really almost all the benefits of reactive programming while using virtual threads. But unfortunately, I can't go into too much more depth just because it's so much more expansive that I really can't do it justice. But also then the other two major features of Project Loom, structure, or at least that initial trifecta of structured concurrency and scope values. Structured concurrency is in its second incubator with JDK 20. It's going to be in its third incubator or maybe preview in JDK 21. And then scoped values, which is a way of being able to share values within like structured concurrency easily that kind of replaces thread local, because when you suddenly have potentially hundreds of thousands, maybe millions of threads using thread locals and then creating hundreds of thousands to millions of those copies of that data can obviously take up a lot of memory. Scope values is an immutable way of sharing data among threads or among virtual threads. Also updated, there's a new enhanced pseudo-random number generator hierarchy. And yeah, this was done in JDK 17. If you're needing to do some random work, then this is kind of updated, because before we had all the splittable, jumpable, leapable, and arbitrarily jumpable randomable, which all have their own particular needs and use cases. But they're all sort of similar, but a little bit different. This kind of unifies the hierarchy to where it's a little bit easier to change between them, or at least a more consistent behavior interface between each of these different types of doing random number generation. And there's also an updating of the underlying algorithms as well. Also, another thing is that Javadoc has also seen a lot of updates for this since over like the past 5 or 6 releases. And one way that's really beneficial is if you go to the official JDK Javadocs, it will actually show you how each of new classes and methods that have been added to classes between releases. So it's a really good way if you kind of want to see some of the changes. Really, one class that has seen a lot of updates since JDK 11 is string, that has had a lot of helper methods that have been added to it. don't have time to go through all that, but if you just go to this link, you can actually easily see a bunch of those changes between the releases. New runtime features. So how many people here have heard of class data sharing? Wow, no one. It's a feature that we do not talk about enough, and because startup times is such a big thing right now, it's a shame because this is how you can easily improve your startup time. So brief history of going back to CDS, which goes all the way back to JDK 5, is whenever you start up your JVM, you're going to be loading a bunch of classes, core classes from the file system, and it's pretty fast, but it could be faster, and that's just repetitive behavior every time. So back in JDK 5, the JVM team, they shared a pre-processed archive for at least Windows installs that will load it from that, and that kind of reduced the startup time. I think it's maybe, well, at least now anymore when I check it out, it's like maybe like a tenth of a second. It's not a huge difference for that, but still a tenth of a second is an improvement. In JDK 9, or 10, that was expanded to also cover application classes. So it wasn't just core JDK classes, but any class that's now your class that or the application you're building can also kind of benefit from this behavior of whenever you're starting it up. It goes through certain loading to make it faster. So when it was first released, it was a very complex process. It was a 3-step process to create one of these shared archives. In JDK 13, it was simplified to a 2-step process. Now in JDK 19, it can all be done in a single-step process to where if a shared archive is available, then it will load from it. And if it's not available, then it'll automatically generate it. So that way, you don't need to, like between development or on your build server, have one set of commands to start up and run it and then have it in production. It can always just be that same consistent command. And then the other part of it is default CDS archive. So I mentioned how in Windows or JDK 5 they had this shared archive. Now it's supported across all the different major platforms. But if you want to create a shared archive, you just simply do auto create shared archive and then give it a name. And then if it's available, it'll be loaded from. And if it's not, it'll be created. But also one of the nice things and two other things with this is that so let's say your organization, or your team, you're all in Spring Boot, or we're all in Quarkus, or MicroProfile, or whatever common tech stack that's pretty similar. The classes that you're writing for your individual application really only make up a small amount of the actual code that's deployed because everything else is in all the different shared libraries. Really, you can just create one shared archive and kind of share it across all those. So you don't necessarily need to be updating ones for this, but actually does it much easier with this create shared archive. But then what's also nice is that it's very robust, that if for some reason it can't find a class file or something in the shared archive, then the JVM will just load it from the file system. Instead, it's not going to throw an error if it can't find that shared archive or it can't find a particular class in that shared archive. So that's also one of the really nice benefits of it as well, that it's about improving the startup time of your application. It's not trying to, it's not going to fail if it's not available. But yeah, it's a pretty noticeable. I think when I've done Spring Boot a few times with it, just running on my local, it maybe takes 6 seconds to start up. And then with a shared archive, it can cut it down to about 4 seconds.
Is that per class loaded?
Per class load? No.
Just a part of the system class loaded?
Yeah, I believe so, yeah.
Okay, so if I have a large app server that loads 90% of its classes via OSGI, that's basically not helping development.
Yeah, I guess I haven't tried it, or I haven't really gone to that use case. I'll have to check with the team members on how it would work with OSGI. Yep. ZGC, so our newest garbage collector, it was finally finalized as a production feature in JDK 15. It is really cool. It can scale up to multi-terabyte heaps. I believe it's 16 terabytes. But what's really nice is the performance of it is consistent. So whether it's your heap size is 50 megabytes or 16 terabytes, at least the pause times would remain that consistent sub-milliseconds pause time, and it's really usually sub 500 microseconds even usually. But yeah, so definitely check it out. It's made to be very easy to configure, so just turn it on, set the heap size, and particularly with this is, so let's say you're expecting the live set of your application to be 2 gigabytes, you would definitely probably want to have a lot of headroom, possibly doubling it. That gives you the best performance. So that way it's not using too much CPU time up. So like, you would probably set it to about 4 gigabytes. I did release a video, an amazing video, if I say so myself. You can check it out here. That kind of goes over the architecture of ZDC. So you can kind of check that out to get into more depth. But what's really also interesting is generational ZDC. So right now ZDC is only single generation, which means that it's scanning the entire heap every time to see what sort of objects have died. Generational ZDC is going to break it up to where newly created objects are put it in one location, because most of the time there's a thing called the weak generational hypothesis that a newly created object usually soon dies. So it's, after enough time, it will move into an older generation that's just not scanned as often. The long and short of it is that generational CGC should require smaller heap sizes, or to be more efficient with memory and more efficient with CPU cycles, because it's no longer trying to scan the entire heap every time to see which objects are no longer reachable. It's looking for a more particular region of the heap where more often objects are no longer reachable. Helpful null pointer exceptions. We all love null pointer exceptions. We also love it how, we get to a line and there's could be 3 different areas that could be null. Now, since JDK 14, you can turn on, or by default, I think it's with JDK 16 maybe, null pointer exceptions are now will be helpful, and it will actually say what specific variable on that line was actually null. That way you don't have to have that really annoying path of, okay, I need to put a log statement to find out what's actually being null and then actually fixing it. Now you can actually find that out just from that first NPE. Yeah, exactly. And then our ARM Architecture 64 support. Since JDK 17, it is supported across all the major platforms. So I'm having trouble wanting to show all the visualization of the performance improvements, but yeah, with every release of JDK, there's dozens to really probably usually hundreds of small changes here and there that improve performance. Most of the time, each of these individual changes, you probably won't necessarily notice. Sometimes you might notice it. I believe in JDK 18, there was an improvement to the string formatting, which actually reduced the throughput time or increased it by 3-fold. So sometimes, if you're using a lot of string formatting, you may have noticed that. But yeah, just improve throughput, reduce memory usage, stuff like that with every release. And it really starts to add up between JDK 8 to JDK 11 to JDK 20. Between those, it starts to add up to be pretty substantial improvements as far as performance goes. So if nothing else, you're trying to convince your management as to why you should upgrade to the newest version of the JDK, this can be a good one, particularly if you're on a public cloud. That can be a real cost savings as well. You may actually require fewer instances or less memory to perform the same amount of work. So as we add things, we are also being good stewards and removing things or making some general changes as well that are important to know about. So how many people here have used a security manager? 1, 2, okay, so that is part of the reason why it's going away. The other part is that really primarily the reason the security manager, we're not making Java less secure, but primarily the reason the security manager was there was for the applet API. And of course, applets was a way of bringing in some sort of external code to run on top of your JVM. And in that world, you would want to have some sort of security to where someone added an applet into your running JVM and didn't suddenly have access to your entire file system. And obviously do some bad monkeying around in that way. So really with the applet API, and sorry, applet developers, going away here very soon, that also reduced really the need for the security manager, because fundamentally, if you're running an application, you're just probably running a Docker container, or all the same, it's all code that you kind of built locally or on your server. You may be bringing in some sort of libraries, of course, but you can do static security analysis on that. So really, OS level security is just a lot easier way of implementing that. There has been a few removals. The Nashorn JavaScript engine, that was removed in JDK 15. It is still being somewhat supported. They're, I think, under the OpenJDK project GitHub page, you can actually still find the Nashorn JavaScript engine. So if you still want to use that, you can, build it. And I think we even provide binaries for it, and bring it in as a library. It's just no longer packaged as part of the JDK. And then the CMS garbage collector, that was also removed in JDK 14, just because it was really a case between the G1 being a better default and then also GGC being available. It just kind of made it no longer the CMS garbage collector just no longer really had a niche that really it provided. Also, lastly, starting with JDK 9, we started with Project Jigsaw and modularity. We started encapsulating the internals of the JDK, and that's definitely continuing very much more so with JDK 17. So before, since JDK 9, by default, the illegal access permit JVM argument was a default argument. In JDK 16, it was no longer default, and then JDK 17, this is a no-op. So now, if you do need to get access to it, you will actually have to explicitly define those different provide access tos for the modules. But also for things like SunMist, like unsafe and signal handler, and several other key classes that are quite important. They still remain accessible by default, but hopefully in the coming years, as library developers can use better alternatives, we can start to make those unaccessible by default as well. All right, we'll get into the beyond portion. Actually, doing a little bit better in time than I was expecting. So unnamed patterns and variables. So we kind of saw in a little bit earlier, with record patterns, how that will make it that much easier to extract data out of a record, but it can still be a bit messy. So let's say here, all I really want, I have these 4 records, a customer that has the billing address and name records within it, and the billing address also has the address record, and so on. So let's say really all I want to work with is the address that's part of billing. I would still have to define all these other different variables, even though I have no intent of using them. So with unnamed patterns and variables, if I have no intent of using the name or age or address for customer, I can just define it with an underscore to say, nope, I don't care about that. And really all I care about billing address. So not only, again, does it just reduce the amount of typing, but it makes it very clear you're looking at this if statement okay, yep, absolutely, obviously, the only thing I care about in this is the billing address and nothing else. So that just makes it actually also more readable in what the intent of this code is as well. And yeah, just another example where it's I don't even have to bother trying to extract all the information out of the billing as well. So that just makes it that much cleaner and easier to work with. You can also do unnamed variables. So let's say for some reason I'm defining a for loop here, and I'm not going to actually do anything with the name variable, the end variable I'm setting here. Then I can simply set it to a underscore to indicate that I'm not going to do any work with it, and then it just helps a little bit when it comes to showing the intent of the code, that you're not intending to do anything with this variable, but because of certain practices, we still need to define it anyways. Now you can kind of just skip that. Another thing, also with exceptions, here in this case, I have a string that's supposed to be age, but it's cat, which is clearly not an age, and you may have a try catch, and you have an illegal argument exception. And really all you're going to do is just saying well, okay, this variable isn't, correct, but you're not going to do anything with that stack trace. Again, here you can just simply say, yeah, I'm not going to do anything with that exception. Just, you can ignore it. And you can just have the rest of your catch here. Again, just more clarity in the intent of your code. Oh yeah, I covered structured concurrency before. And then the vector API. I've always just been very much a web Java developer, so I've never had to use the things like the vector API or the foreign function and memory interface, which are all the deliverables coming out of Panama. So if you're doing like image processing or having to do work with vectors, like this is going to be really great, but it is going to remain in incubator status pending some delivery of Valhalla. Just because once Valhalla delivers from, particularly I believe it's the value types is what they're waiting for the vector API, that will substantially improve the memory management and some of the API for vector, but we're not going to deliver it until that's ready, just because, well, we kind of learned earlier from things like serializable, let's not actually put something out there that isn't completely ready and then regret it for a long time. So we kind of learned that lesson. And so vector will remain in incubator status until that stuff is ready, hopefully soon, but I don't quote me on that. Yeah, like same thing. And then foreign function memory API again. It's not really an area that I personally have worked a whole lot with, but hopefully, that will be delivered here pretty soon as well. One thing I'm really excited about. Brian Getz also wrote a really great article on paving the on-ramp. And so I remember thinking like a while back, like how would I go about like explaining Java to where when you're writing your first program, like you're covering everything that's actually happening. Because I kind of remembered way back when, like, when you wrote your first Hello World, that it's like writing, like it's like a spell incantation. It's like, okay, you need to have your public static void main, system out, print line, hello world. And it's like, you just have to write in this exact way and it'll work. And there's so much actually going on there that, just the professor or your teacher is just saying like, just follow this and, maybe it'll kind of go back and cover all of that. But like, it does mean that also sometimes like that stuff maybe isn't covered all that well. So one of the things we're looking to do is have a more clear on-ramp on how to do that. And that is part of that's being started with this draft step where we're looking at simplifying the main method and some of the requirements around the main class to where you can just have like pub or just simply like main and not necessarily have to have like string args within it. That way it's just much clearer for teaching perspective of like you can just introduce like, okay, let's first talk about methods, then we can talk about arrays, then we can talk about classes, then we can talk accessibility or accessors and stuff like that. For teachers and learning Java, you can have a much more clear on-ramp, introducing new concepts one step at a time. So that way students have a little bit easier way of learning Java. But I know many here, all of us here probably are no longer students. And even then, a lot of this stuff is very beneficial, at least in my job. Like sometimes like I'm just wanting to format some data or extract something, like read like a file or something. I'm terrible with Bash. Like I remember learning it way back in college and I haven't kept up with it. And like every time I look at it, like I have no idea what's going on. A lot of these changes between like things like var, records, being able to launch single file applications have made it a lot easier to use Java as a scripting language. And so some of these changes as well between enhanced main methods and being able to launch multi-file source code programs will also continue as for us more professional developers to make it a bit easier if you need to do some scripting and you don't know Bash or some other scripting language. You can just use Java to kind of write that out to like format some code, extract some data out of a file or something. And these changes will make it just that much easier since now your main method isn't going to have a bunch of stuff that you don't really care much about. So some follow-up links. Again, I covered a lot of different JDK enhancement proposals, so definitely check out that link to see all the changes or get some more depth on some of the changes that you might be interested in. Check out the release notes. Provides, again, far more depth I can get into for each of these releases. Also, I need to get back to it, but I used to do a thing called Super Java where I give like about a 1 or so minute video on various Java features. I found it personally helpful just because I had to expand out into some areas of the JDK I didn't know well as I started making a lot of those videos, so I found it personally interesting. And I think most of us were on Java 11 or later, but still, if you're still having trouble making it past that jump to Java 11, I would definitely recommend reading this article by a former Netflix engineer about the process he went through to upgrade some applications to Java 11 while he was at Netflix. But also there was also some great presentations here about some new tools and processes on helping to upgrade your Java applications from 8 to 11 or updating your underlying libraries. And really that's about 99% of it is really getting your libraries updated to versions that are compatible with whatever desired version of the JDK you want to be on. And you're mostly going to be there. Of course, there might be some cases where you're going to have to make some updates, but that's usually most of the time what's going on there. So with that said, yeah, thank you for coming. And if there's any questions, I'll be more than happy to answer them.